All right, welcome to 2.8. 2.8 is called proving angle relationships. What we're going to really focus on is just what does the angle relationship give us, and what can we do with it if we're trying to figure out what each angle is worth without using a protractor. So in this case, we're just going to talk about this angle addition postulate real quick. Basically, it's just saying, hey, if we have two angles here, if we have these two angles here, well, together, we can add them together to make a large angle. And that's about all we're going to cover it. We're not going to really focus on the proofs of angles, so we don't need to break them apart like we need to for proofs. So if we talk about this real quick, talk about the minute hand and hour hand of a clock pointing at 4 o'clock, and the second hand, even though on the clock it doesn't look like it's pointing at the 2, but we want it exactly at the 2. So if it's bisecting, if that second hand is bisecting that angle, what is each of these angles worth? Well, if you think of 4 o'clock, 4 o'clock is actually a third of a whole clock and a third of a circle, and the whole degrees in a circle is 360. So if we take a third of that, this large angle here is 120. So we just want to take 120 divided by 2, and that's going to give us 60 degrees for each of those angles. Here, this Quilt Design, it tells us that they make a right angle. So together, right angle, they equal 90 degrees. So all three angles add up to 90. It tells us that two of them, BAC, remember we use 3 letters to determine an angle. So if we follow BAC, we're talking about this angle here. Remember, A is a vertex. And then so we're talking about DAE, we're talking about this angle. So both of these angles are 20. Well, if all three of them have to add up to be 90, together those add up to 40. Well, what does this big one have to be? 50 degrees. So get the idea of those. And again, we're just looking at the angle relationship. This could be something where it brings up the term complementary again. So we would want to know complementary adds up, or two angles that add up to 90 degrees. And in this case, it could be 3, I guess, but most of the time we talk about a pair. So here's supplementary, complementary. We talked about those in chapter 1, so they're there for you to look back to and read, jog your memory a little bit. So a linear pair, remember, a linear pair is just a supplementary pair, and this is a good example of a linear pair. So in this case, what do we know about linear pair? They add up to 180, so measurement of angle 1 plus the measurement of angle 2 equals 180. And if measure angle 2 is 166, how would you solve for the measurement of angle 1? Subtract 160 from both sides, and measurement of angle 1 equals 14 degrees. Here, two angles are complementary. Again, we just talked about complementary angles. Reminder, those two angles add up to be 90. So if it helps to draw a visual pair, so angle 1, angle 2. Angle 1 is 62 degrees. What does angle 2 have to be? And you don't have to be so formal. You know, you'd have to, 92 would be total, subtract 62 from it. So we get 28 on that. So, all right, so we know what we're doing with those type of angle relationships. This is just quick reflexive symmetric property, transitive property. We bring this up because in chapter 4, we're going to have to know these to help us understand. But just remember, reflexive, transitive, and symmetric refers to anything, any shape, line, in this case angles. They're all congruent to each other, so we can switch them around. So an angle is reflexive to itself, or I always say, look in the mirror, you see your reflection. Symmetric, we can switch them around. And then transitive, if 1 equals 2 and 2 equals 3, then we know 1 equals 3. And if you guys kind of remember earlier in this chapter, law of syllogism, to me there's kind of a relationship there where P equals or P implies Q and Q implies R. Well, if we know P is going to happen, then we know R is going to happen. So it's kind of the same thing here. So anyways, these are just, again, more proof things, but I think it's important for you to understand. You can read through this all you want to, but if I say angle 1 is 30 degrees and it's supplementary to angle 2, well, then angle 2 has to be 50 degrees. Well, if I say 2 and 3 are supplementary to each other, well, then 3 would have to be 30 degrees. Well, what does that say about angle 1 and angle 3? They have to have the same measurement, so therefore their angles are always going to be congruent to each other. Same thing here, and complementary. If angle 1 is complementary to angle 2, if angle 1's 20, angle 2 has to be 70. If 2 and 3 are complementary to each other, well, then angle 3 has to be 20. Well, what do we know about angle 1 and angle 3 again? Their measurements are equal, therefore we know the angles are congruent to each other. So, and that's all that's saying, and just, I think you guys could understand that, but just so we see it down the road, you know what you're doing. So, vertical angles. Remember vertical angles? What do we know about vertical angles? Vertical angles are always congruent. So, even though, I apologize, this is saying 1 and 2, it really has nothing to do with this drawing up here. So, we'll just draw our own. So, we'll say angle 1 and angle 2. So, angle 1 is D minus 32, and angle 2 is 175 minus 2D. Again, what do we know? We know they're congruent to each other. If they're congruent to each other, their measurements have to be equal to each other. So I can set them equal to each other. Move my 32 over here to the right. So I get 207, I think. Yep. And add 2D over here, I get 3D. And when I divide by 3, D equals 69, so that helps me find my angles. So I can go plug them back in. Now, that D equals 69 is not the answer. We have to plug that back in. So angle 1, D minus 32. Angle 1 is 37. And if we do that with angle 2, 2 times 69 is 138. And 175 minus 138 is going to give us 37 also. So, and the last one. Whoops, got a little typing here. Oh well, we'll get through that. And then here, vertical angles again, very similar to the last one. What do we have? I don't know why we use angle A and angle Z. I don't think I've ever seen it like this, but it is what it is. But again, we know their measurements are equal to each other. So 3B minus 23 equals 152 minus 4B. And I should have had you guys hit pause and see if you can figure this out by yourself. You can do that now, but obviously a lot of geometry is being able to set up the algebra problem. I think we're really good with our algebra skills. So once we have it set up, it should take care of itself. Here we'd add 4B to both sides. We get 7B, add 23 to that, and we get 175. Is that right? Yep. And from there, what do we get? Divide both sides by 7, and we get 25, I believe. 7 goes into 17 twice with 3 remaining, so that makes it 35. And then 35 divided by 7 would be 25. So we get B equals 25. And then at the bottom, just right angle theorems. Just more you know about right angles. I think if you read through those, you're like, oh, that makes sense. So I'll just let you read through those, and we'll see you. And that's it for chapter 2. So we'll review the next couple of days, and we'll take a test next week. So thanks, and we'll see you in class.